Hi, hello, namaskara. Welcome back to Diksha Karnataka channel with the previous year paper discussion that we had already had one part before, that is KCET 2023 paper. We had discussed question number 1 to 30. So I hope all of you have liked that video. So if you have, please support us by subscribing to our channel, and also don't forget to press that bell icon so that you will get more and more notifications regarding all the content that we are releasing in our channel. So we are having an extensive discussion on the last 3 years previous year paper. So already we had seen one part, and we are seeing the remaining questions 31 to 60 question in today's part. So further, if you have any request from your side, and throughout this video, if at all you have anything to let us know, any contradictions in any calculations, anything, any type of doubts or anything that you want to let us know, please use the chat section or the comment section to let us know what and all your queries are and what do you want to convey us. Also, all the question papers, PDF, and the further plannings and the programs tasks developed by us are released in our WhatsApp channel. So please do join our WhatsApp channel. The link is given in the description box. Don't forget to do that. All right. So now let us enter the question paper analysis and discussion of the previous pair, that is 2023. So starting from the 31st question, for a given pair of transparent media, the critical angle is maximum for which color has the maximum critical angle? Now, I hope you people are already clear with the concept of total internal reflection and the critical angle. Critical angle is the angle at which, when a light travels from a rarer medium to denser medium, the refracted ray is almost parallel to the interface, okay, almost through the interface, and above, if the critical angle exceeds the angle of incidence exceeds the critical angle, there will be TIR, total internal reflection. But this total internal reflection, this critical angle, if I have to give it as, one second, sorry for that. All right, yes, so which is written as a sine of a C, critical angle C, assume it as C, is equal to 1 by mu, where mu being the refractive index. So that means that the critical angle is inversely proportional to refractive index. Refractive index is inversely proportional to velocity, which we already know. So denser the optically more denser the object is, less will be the velocity of light passing through it. So therefore, if the refractive index is less, okay, velocity will be more. Refractive index is more, velocity will be less. Inversely proportional. Already it's a reciprocal, 1 by nu. So this means that this is directly proportional to velocity. Velocity in turn is directly proportional to wavelength, right? Because the frequency remains constant, so velocity is directly proportional to wavelength. Now we have to connect these both, critical angle and wavelength. So that means that a particular light of of a particular color, of a particular wavelength, it has a direct relation with the critical angle. That means as the wavelength of a particular light progresses, the critical angle also increases. That means that in this lot, red has the maximum wavelength. That implies that which color will have maximum critical angle? That will be red. So obviously the correct answer is option A. So this is a very important point. Please keep it in mind that critical angle is directly proportional to wavelength. So more the wavelength, the more will be the critical angle. What does more critical angle means? It is not very easy for the light to get totally internal reflected on this particular color. You need to have a very high angle of incidence. Your angle of incidence must exceed that large critical angle so as to get total internal reflected. All right, that means violet, indigo, blue and all will get totally internal reflected very easily because wavelength is less, critical angle is less. Correct. Let's look at the next question, shall we? So before that, I just want to give you another reminder that we are actually planning for a Lakshya KCET crash course, which we do every year. It's a program for 28 days. So all those people who are very serious with their preparation and you need a last minute brush up, so we are here to help you. So any further details about the Lakshya crash course, I am requesting you to again please please join our WhatsApp channel as soon as possible. The link is given in the description box. So join for further updates. All right, and this would really fare very good for those people who are dreaming to score very high and dreaming to join one of the top prestigious institutes in the state. All right, now coming to the 32nd question, an equiconvex lens made up of glass of refractive index 3 by 2, okay, refractive index 3 by 2, has focal length f in the air. it is completely immersed in water of refractive index 4/3, the percentage change in the focal length is. Now, first of all, let me tell you, this concept must be, most of you must be aware of this. When you immerse a particular lens of a particular material in water, given that the water or the liquid refractive index is less than the material refractive index, obviously the focal length increases. That is in air with compared to water. Okay, so in the water, focal length will increase. All right, so that is one thing. What happens? The percentage change is what you want to see. How much is the percentage change in the focal length? So first you have to note that the formula used over here is lens maker's formula. So lens maker's formula first you can use for the normal, that is the in the air. Okay, so 1 by f air. So when you consider the medium air, then we can later see this thing. So we have normal, the absolute refractive index, because you are relating with air. So n minus 1, or you can write one second, mu minus 1, because we have already used this sign mu, let it be mu minus 1, okay, of the material directly, 3/2, whatever that is for glass given, and the simple thing is 1 by r1 minus 1 by r2, okay. So of course the sign convention will come into play and you have to go through all that. Fine, so that's not our issue, because now when I write it in water, okay, so what happens here is, now you do not take the absolute refractive index, rather you take the relative refractive index, which is like of glass divided by mu of water minus 1 into the same thing, 1 by r1 plus 1 by r2. Now the obvious thing that you can do here is take the ratio. Okay, so you can take the ratio directly, you can take so water will go up and air will come down, water and in air. Okay, so this will remain as it is because now there is no change in this. So mu, that is of glass, 3/2 minus 1, okay, whole divided by mu glass by water. That is, now this is tricky, so we have two ratios here. Glass is once again 3/2 and the water is 4/3. Okay, 3/2 by 4/3 minus 1. Okay, so what happens here is the right question. So what happens here is that, so you have 3/2, okay, minus 1 is 1/2, fine, minus 1 is 1/2 whole divided by 3/2 by 4/3, that is 9/8 minus 1/8, sorry, 9/8 minus 1, just you can simplify this, 3 goes up, 2 comes down, 9/8, that is 1/2 divided by 1/8. So this is 4 and 4 goes up 4 times, yes. So actually what happens here is that the focal length is increasing. And how much is that? The focal length in water is 4 times the focal length in air. That means there is an increase of 400%. There is an increase of 400%. It's 4 times. So you can assume that it's an increase of 400%. All right. So this is a very, very critical question you have to keep in mind. So these kind of questions do repeat. So please mark this question as very, very important. Please mark this question as very important. All right. So in air, focal length, and in water. So the crucial thing that you have to keep in here is that when you have a different liquid, the lens maker's equation will have a relative refractive index instead of absolute refractive index. When it is air, it's absolute refractive index. When it's a different medium like another liquid, you will have a relative refractive index. Now also there can be questions like, what if the refractive index of the liquid in which it is immersed is more than that of the solid, like glass. So if the liquid has more refractive index than glass, then what will happen? Yes, so these kind of questions come. So please let me know in the comment section. It's an extra task for you. So what if you dip, now that air has a lesser refractive index, 4/3 is 1.3, 3/2 is 1.5. Glass has obviously greater refractive index than water. What if you dip your glass inside a liquid of a greater refractive index. So please let me know that. Okay, so it's not 400%. I'm sorry, just there's a correction over here. It's not exactly 400%. So the change, they are asking how much is the change, right? How much is the increase? They are not asking the final, how much is the increase. Now F water, that finally it is 4 times F air. So actually it is F air. Initially it is F air. Finally it is 4 times F air. So what is the change in the focal length? It is 4F minus normal F. 4 times in air, then in air. So that is 3 times S. Now you can say it is 300% increase. It's not 400%. I'm sorry for that. I maybe gave that a wrong notion, but it's actually 300 because they are asking the percentage change. So that is actually 300% increase. Okay, so please keep that in mind. All these small minute wordings are very, very important. Good that I remember at the right time. Okay, so it is 300%. Once again, all these calculations are done right in front of you. Even then, if you have any contradiction or anything that you want to claim, that you want to interchange, or you want to let me know something, that there is an error or you have some confusion, please let me know in the comment section. All right. So let us look at the next question. A point object is moving at a velocity of 1 meter per second along the principal axis, okay, of a convex lens of focal length 10 centimeter. The speed of the image is also 1 meter per second. So both of them are having same image, same speed. When the object at dash centimeter, when the object is at dash centimeter, okay, so they are asking what distance from the optical center of the lens. Okay, so where is the image? They are asking that. So object is at some point, okay, object, okay, where they are asking where is the object. Now here there are two conditions. First of all, the object velocity is equal to image velocity. Okay, image velocity. Now this formula, I don't know how many of you know or aware of the velocity of object and images. Okay, so when the object and images are moving, so what is the velocity? I don't know if it is still considered because it's not there in the PU portion. So I highly doubt this question might repeat, but still, let me just give you this particular formula. It's very, very important. So you can take down that image velocity by object velocity. This ratio is given as equal to V square by U square. This is a very, very important result. You can take a note of it if you hadn't any idea, if you didn't have any idea about this. So image velocity divided by object velocity is simply V square by U square. Object distance square, so image distance square by object distance square. Now that they both are equal, okay, so numerator denominator are equal, that this implies that V square is equal to U square, which implies that V is equal to U. Okay, mod is, the magnitude is same, so they can be negative or positive, whatever it is, but magnitude wise they are same, numerically they are the same. So how is this possible? When is the object distance and image distance equal for a convex lens? This is only possible when the object is at a center of curvature. Okay, so focal length is 10 centimeters. So obviously all of you know the center of curvature is at a position double the focal length, that is 20 centimeters. The correct answer is option C, 20. So this is the clue. Object distance, object velocity, image velocity same. That means object distance, image distance are same. That means that if the focal length is 10, the object is at C, that is R, radius of curvature distance away from the optical center, that is 20. All right, fine. This is actually a very simple question. Okay, very easy question if you knew the formula. So most of you have a problem, like they wouldn't have known the formula. If you know the formula, it's very simple. Okay, this again another very simple question. When light propagates through a given homogeneous medium, the velocities of primary wavefronts are lesser than that of the secondary wavelength. Primary wavefront and wavelets are equal. Primary wavefronts and greater than equal to the secondary wavelets. Primary wavefronts are okay. So now basically you are talking about speed of light. Now speed of light is one of the rarest of the rare entities in the universe which is not affected by the relativity or relativistic perspective. Okay, that means that something is greater or lesser. It only happens when it moves from one medium to another. Okay, that is because of the medium. Okay, medium's behavior, that light has a different velocity. But as long as the medium is maintained, there is no relativistic effect on light. So the correct answer over here is option B. Primary wavefront and wavelet will have the same velocity. They won't have any different velocity, not one greater than other or less than. No, velocity of light is same for both primary wavefront as well as wavelet. Alright, very important point, though it's very simple. Please keep it in mind. Next question. Now this is again once again a topic which is now not available in the PUC, so it's highly doubtful that it will be asked for the KCET 2024. Anyway, let me just give you the answer. So they are asking, they are given a graph. So basically they are talking about the sharpness, okay, of a sharpness of a resonance. So there is a resonance point here, that is 500 hertz. Okay, 500 hertz is the angular resonance frequency. So Q factor of the series is, now Q factor formula is actually given by omega naught resonance this thing by 2 delta omega, that is the variation. So you can see variation is 200 and omega naught is 500. So 500 by 2 into 200. Okay, 500 by 200. The variation is only 100. That's sorry. So total gap, that's what total gap is, not 200. It is 100. The total gap there is, yes, it is 200. Yes, now it is 2.5, correct. So the correct answer is 2.5, yes. So the total distance, this is the 2 delta. Alright, fine. So bandwidth. So this anyway, it's very unlikely to repeat in the KCET 2024, but still as a matter of like a question present in the previous year, we can have a look at it. Okay, actually difficulty wise, it's a very simple question. Yes, in the Young's double slit experiment, the intensity of light passing through each of the two double slit is 2 into 10 to the power minus 2 Weber per meter square. The screen slit distance is very large in comparison with the slit to slit distance. That means obviously what this means is that the D is very less. Okay, fine. Yes, slit separation. The fringe width is beta. The distance between the central maximum and the point P on the screen is beta by 3. Then the total light intensity at that point is. Now, this question has again a very simple approach. So there is a lot of thing that you can write and do it, but this is a very standard question. Okay, you can mark this question as an important question because it's a very standard question. They have given you a point, okay, random point on the screen. There are a lot of bright and dark fringes, and they have given you some clue about that position. Okay, it is beta by 3. Sometimes they give you a number. So how do you find the intensity at that point directly? How do you find the intensity at that point directly? This is, you find it using a formula. Please make a note of this formula. Very important. So at some point P, so randomly at some point P, it is given as 4 I naught, the original intensity, okay, that is 2 into 10 to the, alright, into cos square. Usually it is 5 by 2, phase difference by 2. That's the general formula. But here in this particular situation, for this type of question, you can take down pi into x divided by beta. So this is a very important result. X is the position of that particular point from the central maximum. So that is given by beta by 3. You can substitute beta by 3. Ultimately, you will get cos pi by 3 1 by 2 whole square 1 by 4. 4 will get cancelled. IP is equal to I naught. Okay, so you can do the substitution yourself. X is given. You can substitute it here. Okay, so beta will get cancelled. Cos square pi by 3. Cos square pi by 3 is 1 by 4. Okay, cos pi by 3 1 by 2 and cos square pi by 3 is 1 by 4. 4 cancel. IP is equal to I naught. Therefore, the correct answer is option C. 2 into 10 to the power minus 2 Weber per meter square. It's just as the I naught value. This is the I naught value. So it is equal to, IP is equal to I naught value, 2 into 10 to the power. Alright, this is the I naught value. Yes. Alright. Yes, so this is again a very important result. Please keep it in mind, students. Alright. And if at all you have any doubt regarding this, anywhere, at any point, any doubt or any hiccups you are finding it difficult to kind of go through, just let me know. Alright. Next question. 60 watt source emits monochromatic light of wavelength 662.5 nanometer. the number of photons emitted per second is. Once again, a very straightforward question, very simple. Just by logic, I'll get you this. Now, there is a direct formula. Okay, so direct formula is that the power is equal to NH nu, where N is the number of photons emitted per second, per unit time or per second, whichever, you can take anyone. Okay, per second, per unit time. So that is the power. Power is given like this: number of photons into h nu, energy of one photon per unit time. So when per unit time comes, it becomes power. Okay, so energy per unit time, that is power, and total number of photons. So you want to find n. Power is given, okay, h is given, nu is not given, they are given wavelength. So you can use that another alternative formula, NHC by lambda. Okay, so the same thing, you can take the alternative formula and you can substitute all the numbers. Power is 60, n is unknown, 6.626 or 6.7, 10 to the power minus 34, h value, c is 3 into 10 to the power 8, whole divided by lambda is given 662.5. okay, yes, so somewhat you can cancel these both, into 10 to the power minus 9. Okay, so all the similar terms can be cancelled at the numerator and denominator, and ultimately you will get the n value. So you can perform the calculation yourself. Okay, just cross multiply and cancel the similar kind of terms, and ultimately you will get the answer as 2 into 10 to the power 20. Okay, photons per second. So the correct answer is option A. Number of photons emitted per second is 2 into 10 to the power 20. Option A is the correct answer. So you can cross check once again this particular calculation. I have directly written the answer. So you can cross check it. So these both will get cancelled. So you will have 100 in the denominator, and a lot of the other things will get cancelled. 3 and 60 will get cancelled on the other side. So by kind of rearranging, you mostly will get 10 to the power 2 into 10 to the power 20. If at all there is any contradiction, if anything you want to counter this, you can let me know in the comment section. All right, this also is very simple question, very formula based question. Just know the formula and get the answer. All right, next question, let's see. And yes, so in an experiment to study the photoelectric effect, the observer observed variation of stopping potential with frequency of the incident radiation as shown in the figure. The slope and the y-intercept of this graph is. Now this again is a very straightforward question. Why? Because this slope is actually a constant. Okay, that's why every metal will have the same slope. It's a constant, and the slope value is actually h by e. The slope value, which is a constant, h by e. As you know, both h and e are constant. Okay, actually logically you can do one thing. You can eliminate everywhere nu, those slope where nu is there. Nu is a variable, it is not a constant. Slope is constant, nu is a variable. So you can't have a variable in the slope. Okay, so slope is fixed, because that is what the concept says. The slope is constant. So you can't have a variable. So if you have that idea itself, you can cancel out 3 options. You can directly arrive at the correct answer, that is HE. Okay, now you can ask me, sir, how that y-intercept came. Now let me tell you. So here you have to use the Einstein's photoelectric equation, that is h nu is equal to h nu naught plus E V naught, correct? So why did I take kinetic energy as electron in the electron volt, that format I'll let you know. Now just rearrange. E V naught is equal to h nu minus h nu naught. Bring the E down. V naught is equal to h nu by E minus h nu naught by E. Alright, V naught here is the y-intercept. Okay, that is, sorry, y-axis represented by V naught. So we have y as V naught, and now nu is the frequency. Okay, frequency is the x-axis. Sorry, frequency x-axis. So nu has come here, x, and this is the slope. This is actually the format of y is equal to mx plus c. Mx plus c, correct? So here m, that is slope, that is h by e, and remaining is the intercept, that is h nu naught minus h nu naught by e. So the correct answer is option D. This is how you arrive at it. Otherwise, if you have the idea that slope is fixed and you can eliminate all these three options. The only option remaining is option D, which you can go for. You needn't even worry about the slope because you have only one option that is correct, so will go ahead with. So use these small techniques, tips and tricks, and you go ahead with the solving very quickly, so that you can look at other options or questions as well. Correct. Next question. In the Rutherford's alpha scattering experiment, as the impact parameter increases, the scattering angle obviously decreases. Impact parameter is the distance between the alpha particle and the nucleus, perpendicular distance between alpha particle and nucleus, okay, the whatever target nucleus. So this is impact parameter represented by small b. So this is actually inversely proportional scattering angle. The more the impact parameter, the farther it is, less repulsion, less scattering. Obviously it's understood, right? There is no doubt on that. So when the impact parameter increases, scattering angle decreases. This is common understanding. If you are well versed with the concept, you will get it very easily. All right. Okay, very simple question. Once again. Now, yes, this you have to think a little bit. This is not very simple. You will have to write multiple equations, compare them, and then do it. If you are confident, like if you have practiced multiple questions, then definitely you will have that confidence and you will be able to do it. It is simply the Rydberg's equation. Okay, when there is electron transition, what happens? Once again, spectral series I think has been taken off the PU syllabus, so I highly doubt once again if this will appear for the examination, but let's give it a go. Okay, so let's write the formula one by one. 1 by lambda 1 is equal to R into which level it is coming from? 2 to 1. 1 by 2 square minus 1 by 1 square. Okay, this is one equation. Second equation, let's write second equation. Lambda 2 is equal to, see, it is coming from third to first. 1 by 3 square minus 1 by 1 square. Okay, this is second equation. Now let's write the third equation somewhere here. So third equation, lambda 3, 1 by lambda 3 is equal to R into, so what do you have? 3 to 2, right? 1 by 3 square minus 2 square. Now if you compare all of them, okay, if you compare 3, that is up to you. So please compare all the 3. Let me give you just a clue. Okay, so 1 by 2 square minus 1 by 1 square, 1 by 3 square minus, just add these both, add 1 and 2, add equation 1 and 2. See, what do you get? LHS and RHS. So you will get that 1 by lambda 1 plus 1 by lambda 2. 1 by 2 square, 1 by 2 square will get cancelled. Here it is positive, here it is negative. They'll get cancelled. So you will get 1 by 3 square minus 1 by 1 square. So that means that just do it yourself, perform it, and if you have any contradiction, anything, any difficulty, please let me know. So adding both, LHS will be 1 by lambda 1 plus 1 by lambda 3, and the RHS will be, R is common, 1 by 3 square will remain, minus 2 square plus 2 square cancel, minus 1 square. So this is nothing but lambda 2. This is nothing but lambda 2. Okay, so compare this both. This is nothing but lambda 2. So 1 by lambda 1 plus 1 by lambda 3 is equal to lambda 2. Just take LCM and rearrange. You will get the answer as option B. Okay, take the LCM, rearrange, take the reciprocal on both the sides. Lambda 2 is equal to lambda 1, lambda 3 by lambda 1 plus 3. So if at all you have any confusion, please let me know. All right, if there is any contradiction, anything that you didn't understand, please let me know. Perform it yourself, you will get a better understanding. Correct. Let's look at the next question. An unpolarized light of intensity I is passed through two polarites, kept one after the other with the other planes parallel to each other. The intensity of light entering from the second Polaroid is 1 by 4. The angle between the pass axis of the Polaroids are. Now see this again, this polarization has been removed in the PU part. So once again, most probably this question is unlikely to repeat in the 2024 KCET. But just to have an idea, you will have a Polaroid, okay, and then you will have two other receivers. Okay, one polarizer, then you have another receiver kind of a thing, that analyzer on the other side, second. Okay, so in this case we are having two analyzers. So polarizer already divides it into half. Okay, then it comes to the other two side. So this final intensity, whatever you are talking about, this is equal to the initial intensity, which is already reduced to half, okay, into cos square of whatever angle, okay, whatever angle the analyzer is fixed at, okay, whatever angle the analyzer is fixed at. So this final intensity is given as I by 4 and or I by 2, I naught is just because I took it as a general representative, I by 2, okay, final is equal to initial. Yes, so this is I by 2 into cos square theta, okay, so I cancel, this is cos square theta is equal to 2, which implies that cos theta, sorry, it's 1 by 2, 1 by 2, and the cos theta is 1 by root 2. So all of you know, if cos theta is 1 by root 2, the answer is 45. So what angle does cos give you a 1 by root 2 result? It is 45. So the correct answer is 45. Alright, so this question once again highly unlikely to repeat, but still keep this noted. Alright. Next question. A nucleus with mass number 220 initially at rest emits an alpha particle. If the Q value of the reaction is 5.5 mega electron volt, calculate the value of the kinetic energy of the alpha particle. Okay. So now here mostly, you know, the energy, Einstein's mass energy relation, the energy comes from mass. Alright. So kinetic energy of the alpha particle is actually a portion of the entire energy released. Now here the Q factor, Q value is 5.5 mega electron volt. That means the total energy released by the reaction or the emitting in the process is 5.5 mega electron volt. Now alpha particle will have a portion of this. Now how much portion will it have? Actually 220 total mass number divided by 4. No, sorry, reduced by 4. That is the alpha particle's mass, gone. Reduced mass divided by the total mass. Okay. So kinetic energy is equal to 220 minus 4 divided by 220 into the Q value. That is, what is the Q value? Total energy released is 5.5. This is the kinetic energy. Okay, kinetic energy is the portion of the total energy released, that is the Q value, and that portion is given in this format. Okay, reduced mass by total mass into that. So which is given as this is 216 by 220 into approximately, okay, let's approximate this to 5.4 mega electron volt. Alright, 5.4 mega electron volt. This is the correct answer. Definitely option C and D are wrong. Okay, so total energy released in the process itself is 5.5 mega electron volt. Alpha particle having a greater energy is not possible. Okay, so that is what logic tells us. C and D is not correct. Option A and B can give you some confusion, but then it is sorted by this. Alright, let's see the next question. Okay, this is a radioactivity question. Radioactivity has been released since a very long time in the PU portion, and it has been non-repetitive in a lot of competitive examinations. So once again, this time we needn't actually focus on this question because most of you wouldn't even have an idea of radioactivity, and mostly it is going to be removed from the next year's KCET. So let's not have a detailed discussion on this because it takes an entire session to understand this. So let's not go there. So let me just give you the answer. The correct answer over here is option A. So if at all there is any requirement of radioactivity, as far as I have known, it's not needed. But if you have any request from your side, just let me know in the comment section. Let me see how many of you are really willing to do that, and we will plan a session possibly later. All right, let's see the next option, shall we? Okay, next question, sorry. When a p-n junction diode is in forward bias, which type of charge carriers flows in the connecting wire? A very important point, important clue. Which charge carriers will be there in the connecting wire? Like majority minority charge carriers are there in the semiconductor. When we are talking about the connecting wire, a conductor, there is only one major or the only source of charge carriers, that is basically the free electrons. All right, no other way. So conductor, connecting wire will have only free electrons as the charge carriers. All right, very simple. I sometimes feel this is a silly question. If you didn't catch this, that's where you are going to have a problem. Otherwise, it's a very silly question. Next, the 45th question says, a full wave rectifier with diodes D1 and D2 is used to rectify 50 Hz alternating voltage. The diode D1 conducts dash times in 1 second. Now you see, we are talking about a full wave rectifier with 2 diodes. Okay, so and the input current has 50 oscillations. So 50 times it goes through a positive and negative cycle in a second. So each positive cycle, so there are 50 positive and negative cycles. So there are 50 positive and 50 negative. So positive is conducted by one diode, negative is conducted by the other diode. So D1 and D2 will both conduct equal number of positives and negatives, right? Because those many positives are conducted by one, negatives are conducted by one. So 50 positives are there in one cycle, 50 positives will be conducted by D1, 50 negatives will be conducted by D2. So how many are conducted by D1? Easily it is 50. Okay. So it is not 25, it's a common perception and that's an error as well. It's not 25, it is 50 because each and every wave is conducted. Okay, positive side, but it is still conducted. Positive or negative, it is conducted, so that is 50. Okay, so it conducts 50 times in a second. All right. So this is a very easy question, but you have to think through. Okay, don't jump into any answer. Fine. Look at the next question. Now this is a truth table question. So this once again has been removed from the PUC syllabus. So I don't know how far this kind of a question will come. So in this kind of question, the best technique is to attempt. Okay, just to give a trial of one or two inputs so that you will get the output of what type of output you will be getting. So just trial and error method would be the best what I suggest. So you can start with assigning values 0, 0 for both of them. See which of them matches, okay, and which doesn't match, just cross them so that it's not the correct answer. So you are getting that is not the correct answer, 0, 0, and just try which one matches. Okay, so this is a NOR gate, this is a NAND gate, okay, and this is an AND gate. So you can give it through this. So 0, 0, 0 will come here and 0 will come here as well. 0, 0. So what will come? Then 1 will come. Then 0 will come. Then both are coming to a NAND gate, which will be 1 again. Okay. So you can see. And the so P is eliminated because 0, 0 is giving me 1. So B is not the correct answer. And similarly, you can do this kind of a method, proceed into eliminating the wrong one, and ultimately you will get the correct answer as option C. So the correct answer is option C. All of them will yield 1 as the result. Okay, so you can try it yourself. I hope most of the campuses must have covered the truth table. So if you have recognized that this is a deleted portion, then you might not have an idea, but still you can give it a try. All right. So the next question is question number 47. The energy gap of an LED is 2.4 electron volt. When the LED is switched on, the momentum of the emitted photon is. Now this is actually a very simple question. You just have to connect the dots. Energy is given and they are asking you the momentum of a light or photon. So you have to connect these two dots. How do you do that? First of all, how do you write energy? So how do you know about energy of a light? Energy E is given as h nu or hc by lambda. Alright, these are the two versions of energy of a photon. Now let's bring in a de Broglie's wavelength because we need the momentum. So de Broglie wavelength tells us the wavelength is given by h by p, or if you just rearrange it a little bit, we will get p is equal to h by lambda. So in the place of h by lambda, let's substitute p, which gives us E is equal to pc, or p is equal to E by c. So these are the given data which we already know. Let's just substitute them. 2.4 into 1.6 10 to the power minus 19 because it's 2.4 electron volt, right? The energy is 2.4 electron volt divided by C3 into 10 to the power 8. So it's just simple calculation, and at the end of the calculation you can check it yourself. It is 1.28 into 10 to the power minus 27. If at all you are having any contradiction, any mismatch with the calculation, please let me know in the comment section. All right, so it's a very simple question. You can go ahead very easily, right? So let us see the next question, that is the question number 48. Now let me remind you, this question once again has been taken off the PUC syllabus. So it's highly likely that this question will repeat. So it's about the beta decay. So beta decay is that, you know, there are two types of beta decay in which electron is emitted along with the antineutrino, positron is emitted with the neutrino. So this kind of a combination, and so here the correct answer, that is how many neutrons will be left in X, is actually 126. Option D is the correct answer over here. All right, 126. So this actually is not of that importance because it's already under scrutiny. by the curriculum team of the KCET curriculum. So let's not have a deep discussion on it because it will consume a lot of time. So let us go to the next question directly, which is a body is moving along a straight line with an initial value of v0, okay, and later its acceleration is constant. Later, after 1 second, its velocity becomes v. The average velocity of the body in a given time is. Now what is average velocity? Average velocity is, over a period of time, is the displacement of the body covered in time t and divided by the time taken, okay, time taken, that is the t itself, correct. Now how do you find the displacement? So we have the equation v square minus u square, that is, here it is initial velocity v0 square, that is equal to 2as, and the displacement is very well given as v square minus v0 square by 2a. Now use this, substitute this over here, displacement in time t. So you will get v square minus v0 square whole divided by 2a. This is, sorry, this is whole divided by time t. 2a comes down, so we have v square minus v0 square by 2at. Simple. Minus divided by 2a. Yes, B. Okay. Just identify this particular answer here, that is option B. And this is the step how to do it. So go about it. Very simple question. Average velocity totally depends on the displacement and the time. So displacement you can get it using the equation of motion, okay, and just substitute in the normal average velocity formula and there you get the answer. Alright, fine, let's look at the next question, shall we? A particle is in uniform circular motion related to one complete revolution of a particle, okay, there is one complete, when it is completing one complete revolution. Which among the statement is incorrect? Okay, very important. Which of the statement is incorrect? They are asking the wrong statement. Now let's analyze the statements one by one. Displacement of the particle is 0. Absolutely, it comes to the same starting position. Displacement is 0. Average velocity of the particle is 0. Correct, because it is having opposite direction as exactly opposite ends. Average speed of the particle is 0. Now this is an incorrect statement as far as the circular motion is concerned. When it completes one complete cycle, the speed doesn't become 0 because speed is a scalar quantity. Okay, it doesn't depend on the direction. So here our answer is option C. Incorrect answer is option C. D is also true. Okay, average acceleration of the particle is 0. Yes, that's also correct. The incorrect option over here is exactly option C. Average speed of a particle is 0. No, that's not possible for a circular motion when it is completing one complete cycle. Very simple question. Okay, very simple question. Now let us look at the next question. Hold on. Yes. So body of mass 10 kg is kept at a horizontal surface. The coefficient of the kinetic friction between the body and the surface is 0.5. The horizontal force of 60 Newton is applicable. Okay, horizontal force of 60 Newton is applicable. Sorry, applied on the body. The resulting acceleration is, see, now we are talking about the resultant force. Now the resultant force is applied force minus frictional force. So there is a body, okay, there is a body on a surface. So there is an actual force of 60 newtons. There is an opposing force, frictional force, and after all this there is a final net force, that is mass into acceleration. So the net force is actually applied force minus frictional force. So what is the frictional force? It is mu into reaction force, right? So the mass is 10 kg, mu into mg, so which is 60 minus 0.5 into 10 into 10, g is also 10, right? So 0.5 into 10 is 50, 60 minus 50, 10. Okay, so my resultant force is 10. The final resultant force, mass into acceleration, is equal to 10. Correct. Final mass into acceleration 10. What is the mass? It's once again 10. So my acceleration, final net acceleration is 1 meter per second. Option D is the correct answer. Once again, very simple question. So you just have to deal with the given situation, that is, there is a mass, already applied force is there, opposite frictional force is there. They are asking the resultant acceleration. Find the resultant force, you can directly find the resultant acceleration. Resultant force applied minus friction and resultant acceleration. Very simple question. No chance of doubt over here, right? Next, a ball of mass 0.2 kg is thrown vertically down from the height of 10 meters. It collides with the floor and loses 50% of its energy and then rises back to the same height. The value of its initial velocity is. Now you are dropping a ball from some height. Okay. So which way, energy is there? There is potential energy. So there is an mgh. Okay. Now ball is coming down, hitting, and it is losing half. If it loses half, it has half remaining in its body. Okay. So there is half of the energy remaining, and what is that energy consisting of? It has half of mv square and it has mgh. Okay. So this is the total what is remaining in it. So half of whatever it was there, which is half mv square plus mgh. So if you just rearrange this, which I leave it up to you, just try to rearrange this, ultimately find the v value. So you will get the v value as m is common everywhere, m will get cancelled. Okay. So you will get ultimate v value as root 2gh. Root 2gh, which is just substituting all the given values. G value is 10, h value is 10. So root 200. So which is approximately 14 meter per second. Okay, so 196 is the square of 14. So 200 is very close to 196. So the square root of 400 is approximately 14 meter per second. So the correct answer is option A, 14 meter per second. So it's a very simple intuitive question. Just you have to think about it, right? So there is an initial energy, and then when it hits the ground and raises to a certain height, so it loses half of its energy, right? Raises back to the same height, rises back to the same height, so it loses half of the energy. So this is how you do it. Fine. Yes. Let's go to the next question, which is 53. The moment of inertia of a body of an axis. Yes. Now this, once again, it's a very simple question, very theory based question. You just need to know the concept of moment of inertia. If you know that properly, you will get the answer. Moment of inertia of a body about an axis does not depend on its shape, does not depend on its size, depends on the position of the axis, does not depend on its mass. Now what is the correct answer here? So the correct answer over here is, first of all, does not depend on the shape is not correct. That's a false statement. It does depend on the shape. How the mass is distributed is very important. Next, does not depend on size, it's not correct. It does depend on its size. Okay, how large it is. Does not depend on its mass is also false. The correct answer over is depends on the position of the axis. It's very, very important. It does depend on the position of the axis. And along with it, intuitively, you know, it depends on the other things as well. So the correct statement over here is option C, does depends on the position of the axis. So as the position of the axis changes, about the axis, the mass distribution also changes, correct? Therefore, the moment of inertia also changes. Alright, fine. So once again, it's a very simple question. If you know the concept, you can definitely get it through, correct? Let us look at the next question, shall we? Yes. Now this, once again, let me remind you, this is something that we have to deal with the parallel and perpendicular theorem of axes. Once again, deleted from the PU portion. So not much chance of appearing in KCET 2024. But just let me just tell you. So you have a question where you have one single disk where the axis is there. And now this disk is attached with 6 other disks. Looks like a hexagon, right? If you connect the center of masses. What is the final moment of inertia in this case? Alright. So final moment of inertia will be the sum of moment of inertia of this. Okay, you have mr square by 2. Okay, plus you have 6 masses. Okay, 6 masses, 6. Each of them will have their own this thing, that is mr square by 2. Okay, and their own, and the position of the mass from the actual axis. So each of them is away from r plus r 2r. Okay, so m into 2r square. So when you take all of this into consideration, add together, ultimately you will get the answer as 55 mr square by 2. Numerator will be 55, denominator 2 mr square. Okay, you just have to calculate this, open up the bracket, and finally you will end up with 55 mr square by 2. Once again, it's one of the deleted portions, so I hope you don't give much consideration to this. Okay, just to let you know. Fine. Next question. The true length of a wire is 3.678 centimeter. True length is 3.678. When the length of its wire is measured using an instrument A, the length of the wire is 3.5 centimeter. And when the length of a wire is measured using another instrument B, it is found to be 3.38. Now, the correct answer is, so they are asking about which is accurate, which is precise. Now here, the concept of accuracy and precision is extremely important. What is accurate? Accurate means that particular measurement which is closest to the actual value. Among 3.5 and 3.38, which is closest to the value? It is 3.5. So 3.5, instrument A is more accurate. Measurement of A is more accurate. So where else is there measurement of A is more accurate? Yes. So the possibility is of option A and D. Now, you see 3.38, it's not very accurate because it's not close to 3.678. 3.5 is more accurate. Okay. But 3.38 has a depth into its measurement. You can measure up to 2 decimal points. Here you can measure up to only 1 decimal point. There is a depth in the measurement. The least count is even more elaborate. So such kind of measurements are precise. What are precise measurements? Where there is a depth in the measurement. You can measure even up to the further decimal points. Okay. So that is precise, and that is option A, where you have absolutely measurement B is also more precise. So the correct answer is measurement A is more accurate, measurement B is more precise. Okay, absolutely correct answer. Fine. A very simple question. You just need the concept of accuracy and precision. Let's look at the next question. Yes, a stretched wire of a material whose Young's modulus y 2 × 10⁻11 has Poisson's ratio 0.25. Its lateral strain EL is equal to 10⁻³ The elastic energy density of the wire is. So what is the elastic density? So once again, Poisson's ratio, actually it's a deleted topic. So anything where the Poisson's ratio comes into the picture is not much of an utility to us. But still, in this question, let me just explain you. The energy density, elastic energy density, small u is given as half stress into strain. Correct. Fine. So now the stress and strain directly, there is no use of applying it here. So what you can do here is you can substitute in place of stress, you can use stress is equal to Young's modulus into strain. Okay, so you can use this substitution. Why? Because Young's modulus is stress by strain. So if you utilize in this particular equation, so you will get U is equal to half into Y into strain square. Okay, half into strain square. So substituting all the given values, that is Poisson's ratio is there and the lateral strain is given. So Poisson's ratio is given as a lateral strain, okay, divided by the longitudinal strain. Okay, divided by the longitudinal strain. Lateral strain divided by the longitudinal strain. So you can put E0 or E1. So you actually need the longitudinal strain here, not the lateral strain. So you can get the longitudinal strain as E0 is equal to longitudinal strain 10⁻³ divided by 0.25. So you can substitute all the values over here. That is a half 2 into 10⁻11 into 10⁻³ divided by 0.25 whole square. Okay, so you can perform all of this. Of course, 2 will get cancelled, and this particular calculation also you can perform, and ultimately you will arrive at the answer as 16 into 10⁵. All right, option D is the correct answer. Yes, this question requires some heavy duty calculation, I do agree. And also, since it is something that you have to deal with the Poisson's ratio, so I don't urge you to have a greater focus on this question because it's already under scrutiny. So have a mild response to this. Fine. The answer is 16 into 10⁵. All right, let us look at the next question. Yes, now this is actually a very important question. I would like you to mark this question. Okay, this is regarding the Bernoulli's principle. Okay, so Bernoulli's principle. So you have a tank, okay, it has 2 levels. So one is the normal level at the top of the closed tank, other level where the efflux is flowing out. So they are asking what is the rate of flow of this. Now rate of flow, all of you know, we know it is area into velocity. Okay, so what is the rate of flow here? So let me write this as A2 V2. Okay, here it is A1 V1. Fine. So this is slightly a calculation heavy question. So you have a lot of calculation. You have a very long equation as well. So let's start with the Bernoulli's equation. Okay, so just stay along with me. So Bernoulli's equation, we compare both the levels. So the first level is top of the tank. So top of the tank has pressure P0 plus a half rho V1 square, okay, plus rho GH, okay, small h. This is equal to the other level. Okay, so other level we have atmospheric pressure PA plus we have that is the kinetic energy rho V2 square. All right. So this is the actual picture. So of the Bernoulli's principle, both the levels, we are comparing both the levels. So here we have the atmospheric pressure PA plus, and it is moving out half rho V2 square. All right. Now comparing all of this, now V1 square is unknown and we don't need it as well because they are asking the rate of the flow of water coming out of the hole. So let's compare V1 and V2. Let's see if we can eliminate V1. So A1 V1 is equal to A2 V2. Okay. So this implies that V1 is equal to A2 V2 by A1. Okay. So A1 is the top portion closed with the cross-sectional area A. So A1 can be considered as A. Okay. So that is given. A1 can be considered as A because that is the top portion. This is A1. So, and now A2. So the diameter of this hole is 2r. That means radius is r. So A2 can be considered as, pi r square divided by A into V2. Okay. So instead of V1, we can write pi r square V2 by A whole square instead of V1 square. So now it is a massive rearrangement. We are doing a lot of rearrangement. We are taking all the velocity components to one side, all the pressure and this particular potential energy component to one side. So take the pressure in one side, P0 minus PA. Okay, this is one component plus rho GH one component. Now this is equal to half rho V1 square, V2 square minus half rho. Now instead of V1, let's write it pi r square V2 by A the whole square. Okay. So in this we can segregate V2 into one side, half rho V2 square, half rho V2 square, and in bracket we have 1 minus pi r square divided by A the whole square. Now this is a very, very small value, pi into r square by A square the whole square. R itself is a very small value, r square the whole square. The entire term will be extremely less, so you can do about with that, and ultimately we will be remaining at this. So let me just yes, I'll show it over here. Ultimately just rearrange, okay, rearrange everything, just cross multiply over here. This 2 will come on the top and the rho will come on the bottom. So ultimately you will have 2 into P0 minus PA, this is one term, okay, plus you have rho, okay, so 2 rho will get cancelled, 2GH, okay, so this is equal to V2 square, this is equal to V2 square, correct. So you can take the square root on both the sides. So V2 is actually root 2GH plus P0 square, okay. So V2 is actually, let me write it over here, V2 is equal to, taking square root, V2 is equal to 2 P0 minus PA plus 2GH, okay. So V2 is equal to 2 root P0 minus Pa plus 2gh, everything under the root like this. Okay, divided by rho, there will be a rho in the denominator. Okay, so like this, and now ultimately you want the what do you want? Rate of flow. So the rate of flow is given as A2 into V2. A2 is pi r square and V2 is this thing. Okay, V2 is this thing. So ultimately the correct answer is option A. So yes, this is a little bit shabby. So you can try it yourself step by step. So as you can see, first establish the Bernoulli's principle, then just rearrange with the given value, that is this. We have to substitute for V1, eliminate V1, and then rearrange the terms. Okay, rearrange the terms as necessary like this, correct? Rearrange the terms, all the pressure and potential energy to one side, all the velocity to one side. So you can take the common things out. So half rho V2 square is common. Okay, so that is taken out. Now what is remaining? 1 minus pi r square by A whole square. So this is a very small quantity, we can neglect it, very small quantity, neglect it. Okay, so now half rho V2 square is equal to P0 minus Pa plus rho gh. Okay, half rho V2 square is equal to P0 minus P2 rho gh. Fine, and then you will get this answer. Okay, so you have 2 P0 minus Pa by rho plus 2gh is equal to V2 square. Fine, and here V2 is ultimately, you can take root. So this is the V2. Okay, just letting you know, let me choose a different color. This is V2. This is V2. Okay, this is what we found out from here. This is the V2 part, and rate of flow. Rate is actually A2 into V2, where A2 is pi r2 square. So this comes over here. Okay. Yes. So finally area is pi r square and V2. So this is the rate of flow, area into velocity. Fine. Yes. Now the concept is very simple, very straightforward. It is simply Bernoulli's equation. You start from Bernoulli's equation, you start rearranging as accordingly, and ultimately find the velocity into area. So that's it. But it's a very calculation heavy question. That's all. Alright, that increases its difficulty. So this question can be definitely kept under the difficult portion. Alright, now look at question number 58. Once again, very simple question, but slightly calculation heavy question this is. So 100 grams of ice at 0 degrees Celsius is mixed with 100 grams of water at 100 degrees Celsius. The final temperature of the mixture is. Very simple. I hope most of you get this kind of question, calorimetric question. You just have to understand. Now some mass of ice, okay, let's say ice is already at 0 degrees Celsius. Now we have water at 100 degrees Celsius. Now they both are coming to some midpoint. Okay, they both are coming to some midpoint where the temperature is T. It is unknown. Okay, that is what is happening. Now in the process, ice is gaining heat. It gains heat, whereas water loses heat. So it's the simple calorimetry, principle of calorimetry, very simple. So if someone is losing heat to someone and that person is gaining, the loss of heat is equal to gain of heat. So who is losing heat? Water is losing heat. Who is gaining heat? Ice is gaining heat. Now ice is solid, it has to melt first, latent heat of energy. So first the heat gained is equal to, heat gained is equal to heat lost. So what is the heat gained by ice? First of all, it has to melt. Okay, latent heat must be there. So that is mass, latent heat is mass into, okay, let me write the formula that will eradicate all the doubts. So first the latent heat ml, okay, that is of latent heat of fusion of ice, mass of ice, okay, into this, and next specific heat, mass of ice into specific heat of water, because it has already melted, specific heat of water, into delta T, temperature change, that is T minus 0. Change in temperature is final minus initial, T minus 0. Now the heat lost by water, that is mass of water into simple S of water, specific heat capacity of water, into 100 minus T. Now what is the difference in temperature 100 minus T. 100 is the greater one minus T. Now substitute all the values. M is 0.1 into L is 3.36 into 10 to the power 5 plus 0.01, sorry 0.1 into 10 to the power yes 4.2 into 10 to the power 3 into T, which is equal to mass of water once again 100 grams 0.1 into this is 4.2 into 10 to the power 3 into 100 minus T. Now you have to solve for T, that's all. So you can cancel all the common terms. Mass is common everywhere. So it's the same mass of ice and water. You can cancel out everywhere. 100 grams of ice, 100 grams of water. Mass can be, and remaining just calculate. Okay, multiply and you have to solve for T. Ultimately, what is the value of T? The value of T is found to be 10 degrees Celsius. Option A is the correct answer. You can solve it. Okay, if at all you are having any contradiction, anything that is countering what we have done here and what you have done among yourself, the calculation, just to check, let me know if there is any contradiction in the comment section. Okay, so the correct answer which is supposed to come is option A, 10 degrees Celsius. Alright, so this is a very important question. Let me remind you students, please make a note of this question. Calorimetry question isn't much asked, but there is a high chance that they can be asked again, because these are the questions which really test your knowledge, test your patience. Okay, how much you can write one by one without missing even a single value. Okay, so the presence of mind and concentration is required at a very high level to solve calorimetric type of questions. All right, yes. Next question, the PV graph of Carnot engine is shown. Okay, now the engine uses 1 mole of ideal gas as working substances from the graph. The area enclosed by PV diagram is, if the heat supplied is 800 joules, 8000 joules. Once again, the heat engine is out of syllabus. Okay, heat engine is out of the question. Heat engine is not present in the PU syllabus, but vaguely Carnot engine is. Carnot engine is present in the syllabus. So let's deal this question seriously. Now, what is the area enclosed by the PV? So you have to literally find the work done, right? Area enclosed by the PV graph is the work done. Now it's a step-by-step process. Now be with me very carefully. So they have 2 points. Okay, one is A and C. So we have temperature at A. This let us take it as T1, and temperature at C, let's take it as T2. Okay, so first we have to find T1 and T2 in order to use the efficiency equation, right? So how do you find T1 and T2? It is obviously the gas equation, nothing else. So PA VA will give you R into TA, which gives that TA is equal to PA VA by R. Now what is PA and VA? It is 1600, okay, kilopascal into 2.5 centimeter cube, 2.5 into 10 to the power minus 6 meter cube in SI units, right? And this is whole divided by R. So you can do the calculation, you will ultimately get 4 by R. Okay, 4 by R. Similarly, please find TB for me. Okay, TC. PC VC divided by R. PC VC divided by R is equal to TC. Okay, this is my T2. TA is nothing but T2. Sorry, T1. TA is nothing but T1. And TC is equal to T2. Now, please calculate it yourself. PC value is 400. This is PC value. And the VC value is 6.25. Similarly, you can substitute, you can find it yourself. So T2 is equal to PC VC by R, which is 2.5 by R. Okay, so you can try it yourself. If there is any contradiction, please let me know in the comment section. So just like we had did PA VA, you can do it PC VC yourself. PC is 400, VC is 6.25. So please do that. And ultimately, the efficiency formula is given as 1 minus T2 divided by T1. Okay, 1 minus T2 divided by T1. And efficiency is work done by heat supplied, 1 minus, now T2 is equal to 2.5 by R, that is 4. So when you divide both of them, sorry, T1 by T2, that's my mistake, T1 by T2, 1 minus T1 by T2, it's not T2 by T1, T1 by T2. So when you do both of them, you will get 4 by 2.5, okay. Cross multiply, work done is equal to Q. Q is equal to 8000. This is the Q value. So Q is equal to 8000 into 1 minus 4 by 2.5. Okay, 1 minus 4 by 2.5, and ultimately you will get the answer as option C. Okay, so you will get the answer as 3000 joules. Alright, so this is the correct answer. So how do you do it? Once again, let me repeat it very quickly, very simple. If you know the concept of entire thermodynamics functions, reversible process, how to find work done through the graph, and also the efficiency of a Carnot engine. So you can get this T1 and T2 very simply. Okay, after that, efficiency is something that you may or may not know depending on the kind of approach that the college has taken. So if you have already learned the kind of efficiency formula, then it's very easy. Eta is work done by heat supplied, which is 1 minus T1 by T2, 1 minus 4 by 2.5, and just you can calculate this. Ultimately you will get the answer as 8000 into 1 minus 4 by 2.5, which is 3000 joules. Okay, so the work done is 3000 joules. Fine. All right, now this is the penultimate question. Let's go to the last question of our discussion, 60th question. When a planet revolves around the sun, in general, for the planet, what is constant? Linear momentum, aerial velocity, angular momentum and aerial velocity, kinetic and potential energy, linear momentum, linear velocity. Now according to Kepler's second law, aerial velocity is constant. Okay, so wherever you see aerial velocity, it's actually the correct answer. Aerial velocity is constant. So we have option A and B where the aerial velocity is constant. But linear momentum, is it constant linear momentum at every point in the orbit? Does it have the same velocity? Does it have the same momentum? No. So linear momentum is actually wrong. The correct answer is angular momentum. So both angular momentum and the aerial velocity remains conserved. Okay, so aerial velocity is constant, angular momentum is conserved, that means it is constant. Okay, so the angular momentum and aerial velocity is constant. It's a very simple question. I really fully confident that most of you will not make a mistake in this. It's a very trivial question, right? So this was the previous year question paper. There are a lot of out of syllabus question. Considering the fact that this year the PUC syllabus is considered as such for the KCET syllabus, so that is still under scrutiny. So we will get a confirmation on that, and I hope most of you have already got a confirmation on that and you can prepare accordingly. This is just to give you an idea of how a previous year question paper looks like and what is the kind of feel that you get while solving it. Okay, so I really hope most of you enjoyed this video. Okay, let me again remind you about the KCET Lakshya crash course program, which is a 28 days program, and it is especially curated for those people who are waiting for that last minute brushing up all the concepts and preparing to score the best marks, best ranks, and getting into the prestigious institute of the state. All right, so those people can consider this seriously. All the details about this program will be put up in our WhatsApp channel, whose link is in the description box. So quickly go there and join to our channel for further updates and all the mock test and PYP and the content related information. So the link is already there. So please, I urge you, all of you, to quickly join the channel for most crucial and latest updates from our end. And so I hope this video has been fruitful to most of you. So if you really liked it, please press the like button, and for further content updation and the notification, press that bell icon, and don't forget to subscribe our channel as well. And lot of aspirants are there looking out for proper decent content. Please share with them, let everybody know that there is someone working for them. So this will be great help for all of them. So this is Krathik signing off. So for more content, please let us know what all is your requirement and what kind of videos you want in the comment section. Until the next time we meet, it is me saying bye, adios.